Alright, let's start talking about it. So don't forget, part of your grade does come from your collaboration within the whole class discussions. Right now, everyone's sitting at 3s and 4s. Alright, so we have a chance to change that. Okay, trying to hit that 5. So, Robert, number 1. If we get all the students in your statistics class to participate in the study, ask them whether or not they study with music on and divide them into 2 groups based on the answer to this question. Is there random sampling?
What?
Do you think there's random sampling in number 1?
Sure. Yeah.
Yeah? Okay. What about random assignment?
That too.
That too? Okay. Anybody want to push back on that?
No, I don't think it's neither.
You don't think it's either?
I knew it was neither.
Okay, Maven, why do you think it's
So what
neither?
is it?
Oh, because like, you said baby.
I didn't say baby.
I help her.
Alright.
It's not random because he got all the students in the class. Like,
Okay, you got all the students in the class. Also, look at number 2. What's there that's not number 1? Random sample, right? If there's a random sample, it needs to say what?
Random sample.
Okay, cool. So, do we have random sample?
No.
Okay. What about random assignment?
No.
Caleb, why do you think they're saying no to random assignment?
Because I got all the students in class.
Is that the issue, or would that be random assignment though?
You're not randomly assigning no one to like general part, like
So,
within the general thing.
we gotta remember, there is a difference, and this is an issue that students earlier had as well. Random sampling means I have my entire population and I randomly take some of those people to collect data from. Random assignment means I have my people and I randomly assign them to a treatment. Either they are listening to music while studying or they are not listening to music while studying. And does it ever say that they randomly assign them to those treatments?
No.
Does that make sense?
Yeah.
Okay. So we have neither of those things. Now, here's where I already have some stuff written on the board and I want to point this out. Yes, ma'am?
I was going to say something about the conclusion.
Okay, we'll get there in a second. Make a prediction about the population based on a sample representative of the population. What am I talking about there?
Observation.
That's an observational study. Okay? We got to know that. That's an observational study. What can prevent an observational study from being able to make that prediction? Bias, right? When the sample is representative of the population, though, that means the sample is what?
Confounded.
Accurate.
Wait, hold on.
Unbiased is the term. Do we ever talk about confounding when we're talking about representing the population? No. That's about bias, right? So we have an unbiased sample, and then that means if the sample is unbiased, it is representative of the population, right? Okay. Treatments are applied to subjects to establish cause and effect between explanatory and response variables.
That's an experiment.
That's an experiment, right? What are we trying to do within this experiment?
Find cause and effect.
So we're going to reduce confounding to what?
Find cause and effect.
To establish cause and effect. Right? And so we're trying to establish cause and effect, so we need to reduce confounding. Because we did not randomly sample and we did not randomly assign, do we have a sample representative of the population? No. So can I make a prediction? Nope. Because I did not randomly assign, did I reduce confounding?
No.
So can I establish cause and effect? Do we see that idea?
Yeah.
So we need to recognize the conclusion here would be that we do not know anything about what would the population be in this case. By the way, don't forget, like, you can have the same idea without it necessarily being the same exact words. You don't have to erase everything. Look to see what the final answer is and update it if you need to. But what do we not know anything about?
Students.
We don't know anything about the student, the population, but let's use the context. What students?
Oh, well, the students in school, in
a
class.
Statistics class.
We don't know anything about the students in the statistics class?
The students, yeah, that's basically the same.
I mean, I feel like I know stuff about the students in the statistics class, don't
You
you?
know students about in the school?
Okay, so remember, we have, this is our what? Sample.
True, true.
The students in the
And
school
they're
is
coming from the
the
school.
population.
Right. We do not know anything about students in the school because the sample is what?
Students in the class.
It is just the students in the class, which means the sample is,
Unbiased.
Or
which one is it?
Unbiased.
It's unbiased. No.
Remember,
No, it's
unbiased
biased because
means
it's
it's
not
representative.
It's biased.
It's
So
not
it
random.
is biased, it's not random,
Yeah.
right? Because the sample is biased. Remember, we don't know anything because it is biased,
Right there.
right? So we do not know anything about students in the school because the sample is biased and we could not establish what? Cause and effect, because there were no treatments. We did not establish cause and effect because there were no treatments. It's important to notice that when we don't have the random sampling, don't have that random assignment, that's going to make it hard to do either kind of study or to complete the objectives of either kind of study. And so we may consider this an observational study, but we don't learn anything from it. Okay? So number 2,
random sample.
random sample. Anybody want to push back on that? We're good with that one?
Yeah.
Okay. Random assignment?
No.
And again, it's got to be pretty clear. Select a
Random sample.
random sample. It tells us that, okay? Because you selected a random sample of students from the entire school, what do we conclude about that sample?
Like read my answer.
Sure.
I would say because we found it was a random sample, we were able to predict that students who listen to music while studying have a lower mean GPA.
Is that fair?
Yep. That's same thing.
Okay. Caleb, what did he say? You don't know? Jade, read it again for us.
Because we found it was a random sample, we were able to predict that students who listen to music while studying have a lower mean GPA.
Why? I think you said it was representative of the population. Can you read the first part again?
I said.
Because the sample was random.
Yeah, sample. Because it was a random sample,
What did you say after that?
we were able to predict.
The population, that's what it was. Caleb, why was he able to make a prediction about the population for with the random sampling? So we gotta know this. Anaya, what does random sampling do?
Helps us make a prediction about the population.
True, but why?
Because it makes it unbiased.
It's unbiased.
So it is reducing
Bias.
bias. We gotta remember that, okay, Caleb? So the idea is, we selected a random sample, so we reduced bias, so our sample should be representative of the population. And so remember, the conclusion was that students in that, or students who listen to music while studying had a lower GPA. Because we randomly selected from the school, that's probably true for the entire school. We get with that idea? Okay? So you don't have to have this exact language, but it's important to notice the random sample should be unbiased. So, we believe students in the school, notice how I'm getting to the whole population, right? Students in the school who listen to music while studying have a what?
Lower mean GPA.
Mm-hmm. I want you to notice, did we say that the music is causing a lower GPA?
No.
Nope, we just know that those students have a lower GPA. That's the difference between there's a relationship, a correlation versus causation. Okay? We can just predict that the population as a whole has a lower GPA because we had random what? Random selection or sample, right? And that random sample reduced what?
Bias.
Bias. You all good with those details? Any questions?
No.
Good. That's what I like to hear. So number 3,
Assignment.
just random assignment?
Yeah.
Yes, because it's what the thing say first of all.
Okay.
But
Put an X.
Sorry, yeah, I should put yes, you are
Oh,
correct.
I thought it was wrong.
Just marking it, but yeah. So, no. Because there was random assignment, Trista, what did we reduce?
Random assignment, confounding.
Confounding, right? Okay, so Emily, if we reduce confounding, what were we able to establish? Emily, any ideas? Okay, so make sure we take notes on this. You done? Just put it in the hanging file folder back there and I'll come grab it at some point. Do not forget, okay, if we reduce bias, nope. Unbiased sample means sample is representative of the population. That's when we can make a prediction, right? So bias is all about making a prediction about the population. Confounding is all about what? Cause and effect. So if we reduce confounding, we're able to establish what? Cause and effect. We good with that? We reduce confounding, we're able to establish cause and effect. Anaya, cause and effect between what two ideas?
students who listen to music while studying.
Okay?
And those
So
who-
students who listen to music do what? Or, sorry,
Well, I'll put
the music does what?
causes them to have lower GPAs.
Right? We can establish, and notice the whole idea is they randomly assign half of the students to listen to music while studying, and have the remaining half abstain from listening to music while studying. Abstain just means not listen to music. And then in that case, those who listen to music had a lower mean GPA. Because we randomly assigned people to those two treatments, either listening to music or not listening to music while studying, we can establish this. We can establish that listening to music lowered their GPA. I do want to point this out. Based on this study, can we make that prediction about the entire population?
No.
We didn't reduce bias, did we?
No.
So we wouldn't be able to make this prediction for the whole population, but for this sample, we can establish that listening to music reduced their GPA. Does that make sense? So an experiment tells us for those people. An observational study helps us make a prediction. So what happens when you have both?
You reduce bias and confounding.
We reduce bias and confounding, so what?
So we establish cause and effect.
We can establish cause and effect,
Which
And then have a
also makes
prediction.
it,
and we can make a prediction about the population.
which makes it representative to a population.
Well, the reduced bias, the unbiased sample means it's representative, right? Which is why we can make that prediction. We get with that? So all I would say here, we can put it in context, but I want to get to one thing before we end. Both things from numbers 2 and 3, right? That's literally what we're finding out, is that we can establish that listening to music lowered their GPA, and that would be true for the entire population, which is the school. Do we understand that idea there? Right? So that Reduction of confounding allows us to establish cause and effect. Reduction of bias allows us to make a prediction about the population. How are we feeling about statistics so far?
Great.
Let's be real with each other. How does maybe a little more practice, but how does statistics compare to most of the math that you've studied up to this point in life?
It's great.
Yeah, this easy to read.
Math problem.
Let's also be real, like, it's more fun, isn't
Yeah,
it?
Instead of doing math problems.
I love statistics.
You talking about
If I could teach statistics all day, every day, I would.
We done with this, what we did.
Yes, we are done with 3.9. We're going to look at the candy grab activity for just a moment, and we'll deal with the Starburst tomorrow. Oh crap, I lied. 3.9, we got one more thing. Actually, no, we're not just packing up. I'm going to ask y'all, I won't do this for a grade, but this will help you significantly. Hold on, listen, okay? I'm not going to collect this for a grade, but it will help you significantly if you do 3.9 and work through this, try to answer those questions, and we'll talk about it tomorrow, okay? Just to save a little bit of time, huh? Just to talk these. Be aware of this 3.9 application. This is homework that will be due on Tuesday. Okay.
What if we do it, so we get a grade for it?
You might well give like
5 points, yeah.
So
So we do this tonight, we bring it back.
If you, yeah, let's say that if you put in, if it's obvious you put in effort and you actually try to answer the top half of 3.9, I'll give you a quick little 5-point
Somebody
grade.
this,
Yep, just the top half.
not this.
This right here is your homework that is due on Tuesday.
Alright.
So make a note of this. This is homework that is due on Tuesday. Okay? Correct. Remember I changed the homework due dates. Alright. So here's the thing. We've learned a lot about creating studies in order to make a prediction about a population, correct?
Yeah.
We've done a lot with experiments to understand how to establish cause and effect. Well, we're actually going to put that into play to try to talk about possible explanatory variables for response variable, which we did that in the bell ringer. We're going to talk about bivariate data with trend lines and use trend lines to extrapolate and interpolate. And we're going to interpret slope. Keep that out, Maven, because we're going to look at the candy grab thing that I just gave y'all. Just because I want to point this out, right here. What is the characteristic of interest for this study?
Starburst.
Starburst, right? So the number of starbursts, what?
You can grab.
Okay, so number of starburst grabbed. Okay, what about what type of study this is?
This is experiment. No, observational study. Wait, Anchor's over here.
This was the bell ringer.
It was an observational
It's an
study.
observational study. You're not changing treatments. So observational study. Finally, what type of conclusion can one draw from this study?
How many starbursts? Or how many,
Oh, come on. We just did a whole thing on conclusions.
Wait.
What kind of conclusion can we draw from this study, right? We're going to look at how many starbursts people can grab. It's observational, so what kind of...
Bias?
Is this a random
you
sample?
gotta predict the
Or is it-
population.
Wait, say that one more time.
Is it a random sample?
If it's a random sample, we can draw what kind of conclusion?
And sample, you can, let me see.
If it's a random sample,
You'll draw an unbiased sample.
okay, if it's a random sample, it's going to be unbiased, so we can make a what?
Prediction.
There we go, right? If a random sample, we can make a prediction about the population. Which the population would just be the whole class. Now, I was planning on doing this in class, we don't have time for this. What I'm going to do is I'm going to randomly select, we got 21 people in this class. Let's say I'll randomly select 8 of y'all tonight. I'll just have, by the way, what am I going to have to use to do a random sample?
Your brain.
Nope.
You gotta use
Generate,
a
That random number
Generator.
generator, okay? I will randomly generate several numbers. I'll even screenshot it so you can see it, and I'm gonna use the cell phone numbers on the caddy to determine who I select. Does that make sense? Yep. We good with that? Alright, so what homework is due tomorrow?
The
Workbook stuff, what else? The literacy, the math literacy is due tomorrow, and then the 3.9 is due on
Tuesday.
Tuesday. There we go.
Y'all get my 5 on the report.
Oh yeah, and then you have that optional homework.
He ain't know either though.
Y'all get my 5 on the report.
You're definitely at 4, it's a possible 5, I'm thinking about it.
How about me? I know it's a low.
We did do good today.
Yeah, I know I get 5.
So you get,
I get 5 though.
you get a 5?
Yeah.
I don't know about a 5.
Hello.
No.
Miss, can I say that I love my book?
Oh.
This man trying to suspend me because my pants.
He's suspending you?